Hello everybody. Now today we are going to discuss optics, and under that we are going to consider ray optics. uh, Further into it, we are going to consider reflection of light. Now reflection of light is when we consider any given surface and an incident light ray strikes on the surface at the point of incidence. From the point of incidence you get a reflected light ray, a light ray which bounces back into the same medium from which the incident light ray had approached onto the reflecting surface. And the reflected ray, as it is bouncing back, so basically reflection is the phenomenon of bouncing back. And bouncing back, because we are considering optics, obviously we are considering the bouncing back of the light rays. Okay, now most of the surfaces in the physical world are reflecting ones. Some are good or perfect, while others may not be good or completely bad. Now we'll consider a few examples for that. But obviously all of them must obey the laws of reflection. Now consider this figure where an incident light ray IO that falls at the point O, which is the point of incidence of a reflecting surface given by the arrow is a horizontal one. Let me name it for you. The reflecting surface being suppose I name it as ABCD. Okay, so ABCD is that flat horizontal reflecting surface, and then it gets reflected along OR. Okay, so in this figure, IO is the incident ray, OR is the reflected ray, and ABCD is the reflecting surface. Now what is ON that I have considered over there? Now ON is the normal or perpendicular line that has been considered, and it is an imaginary line just for the sake of reference at the point of incidence O. Now as per the laws of reflection, we have the first law as that the incident ray, the normal, and the normal taken at the point of incidence, and the reflected ray, they lie on the same plane. Same plane being the dotted plane that I have considered, which is WXYZ. So obviously the plane WXYZ is normal to the plane ABCD. That is, if WXYZ goes through the plane ABCD across the line LM, then ON, the normal, has to be perpendicular to LM, the line that we have considered. And the second law states that the angle subtended by the incident ray on the normal at the point of incidence, which is known as the angle of incidence, denoted by the letter I that has come up in the figure. So angle I here is equal to ION angle, and that has to be equal to the angle subtended by the reflected ray onto the normal at the point of incidence. And this is known as the angle of reflection, denoted by R, which is the angle NOR. So the phenomenon of reflection must always occur obeying these laws of reflection. Now consider this figure where we are discussing about regular and diffuse reflections, and we have considered parallel light rays in both the cases, on the left and on the right. The incident light rays onto the surfaces are parallel, and the surfaces, one of them is an even surface, plain, polished, and the other one is an uneven surface, as you can see. So the reflection at both the surfaces must obey the laws of reflection. Now what are the what are the consequences, what we will find after that? Now the angle of incidence in the first figure is I in both the cases, as the light rays are incident, and the normals will also be parallel to one another. Now as I is equal to R, so the reflected light rays will be along the onto the same medium and will have the same angles, and therefore they will be parallel to one another as well, because the incident light rays were parallel, so the reflected light rays will be parallel. But here, as you can see, in the uneven surface, the normals are not parallel anymore, and the angle of incidences therefore are different, I1 and I2, and they will have equal angle of reflections, that is R1 and R2, but R1 and R2 won't be parallel to one another because the normals were not parallel, so they won't be parallel. So the light rays that are reflected are non-parallel. So the reflection in case of the first surface will give us a proper image of an object from which the light rays are incident, and such type of reflection is known as regular reflection. Now, why do I say it will give a proper image? Now, that's because the rays coming from each point of an object are received exactly in the same way after reflection, since the reflected rays are parallel or in order. Now, for that, let me consider an image, that is AB, for which we are getting an image, another image AB. Okay, so the solid AB is the object and the dotted AB is the image which we are getting from the reflected rays. As you can see, from the point A, the incident light ray is reflected to the reflected light ray along the dotted A, and from the point B to the dotted B. So it is a perfect image that we are getting. Whereas in case of reflection in the second surface, that will give nothing or an improper image of any object which is placed, and therefore such a kind of reflection is known as diffuse deflection. So the figure that I had used for uneven or irregular surface is highly magnified. Most surfaces which don't give back a proper reflection will have such unevenness at the microscopic levels. Okay, so even in the day-to-day life that you observe the surfaces, if they are not giving a proper image, means they are uneven. So the papers, the newspapers, or the books we read, or the roads we travel, or the walls of our homes, they do not give a proper image because at the microscopic level they are uneven, and hence the image cannot be obtained. While then, which are the surfaces that we call as proper surfaces which give regular reflections? Now, example can be a plane mirror. Consider a plane mirror, and it has both the sides. One of the sides has been silvered and the other side obviously acts as the reflecting surface. Now, on the reflecting surface, if in front of the reflecting surface I place an object AB, now from that object AB I consider two lines which act normal or fall normal to the reflecting surface. As the light rays are incident normally to the surface, they make zero angles with the imaginary normal of the surface, and hence the angle of incidence is zero. So following the laws of reflection, the angle of reflection has also got to be zero. That is, the light is reflected back along the same line, as you can see from the arrows that have been given. I consider two more parallel rays. I can consider many rays, so I consider two more parallel rays, and they are reflected and reflected parallelly, obviously, but the parallel light rays won't meet. So if I produce them backward, the dotted lines represent the lines or the rays that have been produced backward, so they are not actual rays. So these rays produced backward, they produce the image a prime b prime, that is the image of the object. So as you can see, a prime b prime is of the same size, is at the same distance from the mirror, and it is a virtual image because the reflected light rays don't actually meet to form it, and it is upright obviously. So the same size meaning AB is equal to a prime b prime. Same distance means I have AM to be equal to MA prime or MA dash. And next case is the virtual case, because the reflected light rays that have been ticked, they are produced backward. They have to be produced backward in order to form this image. So that is why it is a virtual object. Virtual means it cannot be obtained on screen. And upright because, as you can see, the base at B and B prime, for B you are getting the image B prime. So the bases are the B prime is the reflected point obviously, so the bases are at the bottom and the top points are what we have at the top. And as I have extended AB into a letter L, as you can see, its image doesn't look like the letter L, it just looks like what I have drawn over there. And this phenomenon is known as lateral inversion. That is, the image gets inverted but laterally. Now, so that is another property of the image formed in case of plane mirror, that the image is laterally inverted. Now, for example, lateral inversion can be observed by the in case of ambulance, where they have written what I have shown at the bottom. They will write it like that, and you will be observing in your mirror, rear view mirror, as the proper letter, that is ambulance, that I have written over at the top. So that's all for this topic as of now. Thank you.